Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera to all of the panel. So we from the group C from Wednesday under Dr. Nur Hidayah binti Ahmad. We want to present about the polarization in liquid. So I am Nur Syahidah binti Abrahman.
I am Syarul bin Saleh.
I am Siti Nabila binti Osman.
Okay. We start with the abstract. The abstract is about the Malus law. Malus law is a law which is initiated by Etienne Los Malus, who was a French officer, engineer, physicist, and mathematician. In general, the sun and many other light sources produce waves that are randomly polarized. So polarized materials invented by Edwin Land act as a polarizing slit for light, allowing only polarization in one direction to pass through. Okay, next. Malus law states that the intensity of light after passing through the polarizer and the analyzer is proportional to the square of the cosine of the angle between them. So this is the formula which used in this study of the experiment. So I equal to I naught cosine of the angle square theta, okay, theta sama lah, okay, where I naught is the intensity of the polarized wave before passing through the filter, I is the intensity of light transmitted through the analyzer, and the angle is the between the axis polarizer and analyzer. So hence our objective to gain from this experiment, we want to determine the relationship between the intensity of the transmitted light through the analyzer and angle of rotation between the axes of polarizer and analyzer by plotting the graph. Second, we want to verify Malus law. Okay, to capture our objectives, we discussed the setup of our experiment, which through this experiment, we use the simple polarimeter by using the polarizer, analyzer, light sources, which is we use red laser, cylinder of various sample solution, which is salt, sugar, and plain water, and the light sensor using the Arduino Science Journal, measure in the lux, and to the light sensor is to measure the intensity of the light, and protector to measure the angle of rotation at analyzer. So we fix all the distance and varying the angle. Okay, we proceed with the introduction. The topic of our experiment is to study the Malus law in polarimeter. So when the two polarizer are placed one after another, hence the second polarizer is called as an analyzer. The angle between the polarization axis act as an value of theta in Malus law. In this experiment, the various sample solution is used to ensure the polarized light will be passes through the sample and analyzer. Hence, we can measure the intensity of the light in lux for various angle of rotation from 0 until the 180. From the Malus law equation, we can see the intensity of the light passes through the analyzer is proportional to the square of cosine theta, when the maximum intensity constant and also the maximum intensity is inversely proportional to the square of the cosine theta while the intensity constant. So in this experiment, we wish to obtain our own result and observe on how the graph of intensity against angle would be verify the Malus law and do the fitting of our graph. Okay. Next, the literature review. Malus law is defined as when completely plane of polarized light is incident on the analyzer, then the intensity of the light transmitted by the analyzer is directly proportional to the square of the cosine theta between the polarization axis of the analyzer and polarization axis of the polarized light. When we observe the light source, which is the red laser, about 650 nanometer through the polarizer, the intensity of polarized light will be decreased and increased as we rotate the analyzer. The intensity of the polarized light will be minimum when the polarization axis of the analyzer is perpendicular with the emitted polarized light. From the first picture, it shows when the polarizer are arranged so that their planes of polarization are perpendicular to each other, then the light is blocked. Then the second picture, when the second filter, which is called the analyzer, is parallel to the first, of all the light passes by the first filter is also transmitted by the second. Okay.
Next, I will talk about the methodology of this experiment. So this is our setup for short solution where we use a red laser, a cylinder, polarizer analyzer, and our phone as a sensor. So the red laser wavelength is 65 nanometer, 650 nanometer, and the distance we set for the red laser to the polarizer is 10 cm, and the distance of polarizer to the salt solution is 10 cm also, and the range of salt water in the cylinder is 9.5 cm. The distance of salt water to analyzer is 10 cm. Distance analyzer to the light source is 10 cm. And this is the setup for sugar solution. As you can see, we vary all the distance for 10 cm. In this setup, the range of the sugar solution in cylinder is 6.3 centimeter. And this is the setup for plain water. And we can see here is the distance also the same, and the range of the plain water in the cylinder is 9.5 centimeter. So the data analysis, this is what we see when using the polarizer and the analyzer. And this is the result of the salt water. As we can see here, the intensity is the highest when 0 degree, and it's getting lower until 90 degree, and it goes, it increases back when reaching 180 degree. So this is our fitting command and our fitting solution. As we can see here, the fitting solution, the fitting result for the salt solution gives a reduced C square of 24.6949. And this is the graph after fitting. And next is the result for sugar solution. So this is the data. And in this case, it is also the same. When 0 degree, the intensity is at the highest, which is 335 lux, and getting low until 70 degree. 70 degree intensity, which is 23 lux, and then it's getting higher until 120 lux at 180 degree. Next is the fitting command and the fitting result. And this is the graph after the fitting. Next one is the result for plain water. So this is the data. As we can see here, when 0 degree, the intensity is 230 lux. And it's getting low until 90 degree, which give 0.6 lux. And it is increasing and then decreasing again at 180 degree. So this is the fitting command and the fitting result. Which the fitting result shows the reduced C-square is 777.499. So this is the graph of the fitting. And next is the result without any solution. So this is the data. So the highest is the when 0 degree, which is 80 lux. And the lowest is when 90 degree and 100 degree, which give 2 lux. So this is the fitting command and the fitting result. Fitting result shows reduce C-square is equals to 113.592. So this is the graph after the fitting. And this is the fitting command for all four graph combined. And this is the graph of every solution, which is the salt, sugar, plain water, and without any sample.
The discussion of this experiment, for the sugar solution, the maximum intensity is 335 lux at the 0 degree, while the intensity become 120 lux at the 180 degree. This is because the sugar molecules are quicker, that is, will rotate the polarization of light passes through to a slightly different polarization. Okay, as we shine the polarized light through the sugar solution, then it will rotate the polarization to a different angle. Okay, for the salt solution, the maximum intensity is 110 lux at 0 degree and 119 lux at 180 degree. And for the minimum intensity is 7.5 lux at the 90 degree. So the maximum intensity achieved due to the polarizer that parallel to the analyzer. Hence, most of the light passed by the polarizer and also transmitted by the analyzer. So the minimum intensity achieved due to the polarizer and the analyzer are arranged so that their planes of polarization are perpendicular to each other. Hence, less light can pass through. Next. Okay. For the plain water, the maximum intensity is 230 lux at 0 degree and 169 lux at 10 degree. And for the minimum intensity is 0.6 at 90 degree. This is due to the same concept of sunglasses, which is the light gets bright and dim when we rotate, but not completely black. This is due to the reflected light is partially polarized and cannot be completely blocked by a polarizing filter. Different types of solution produce different value of lux that can pass through to the analyzer. As we can see at the salt, sugar, and plain water. Okay. We also conduct the experiment without sample to analyze the effect of liquid in polarization. The maximum intensity is 80 lux at 0 degree. Meanwhile, the minimum intensity is 2 lux at 90 and 100 degree respectively. As we know that unpolarized light has equal amounts of vertical and horizontal polarization. So, after the interaction with a surface, the vertical components are preferentially absorbed or refracted, leaving the reflected light more horizontally polarized. Okay. As the conclusion, I equals to I naught cos squared theta, which is from the Malus law, was verified by compare it to the parabolic equation of y equals to ax squared plus bx plus c, where the I naught is the a and cos squared theta is the x squared. So the graph will be looked as the parabolic curve, which is graph of intensity against angle were plotted. As the conclusion, light wave is an electromagnetic wave that travels through the vacuum of outer space, and light waves are produced by vibrating electric charges. Light wave can be polarized by passing it through a polarizing filter or other polarizing material. The intensity I of polarized light after passing through a polarizing filter is I equals to I naught cos square theta, where I naught is the original intensity and theta is the angle between the direction of polarization and the axis of the filter. Throughout this experiment, that using the polarizer, it is clear that the light intensity decreases when rotating the analyzer perpendicular to the polarizer, and light intensity will increase when rotate the analyzer parallel to polarizer. Error were encountered when repositioning the polarizer, as it is difficult to see it at the precise angles, and also the sensor detecting ambient light from other light sources. That this maybe will be interrupt the data of the intensity. So as the precaution for the experiment is to do this experiment in the dark room and take multiple readings to obtain more accurate data. So in conclusion, different solutions will give the different intensity as the molecules of the solution is different, but effect the polarization is still same, where light intensity is the lowest when polarizers is perpendicular to each other and the highest when parallel to each other. That's all from us. Thank you.